Welcome to this lecture. This lecture is on diffusion current. Myself, Sarana Kumar, Assistant Professor, Department of Electrical and Electronics Engineering, Hindustan College of Engineering and Technology, Coimbatore. Content of this lecture: Introduction, diffusion in PN junctions, formation of depletion region, establishment of equilibrium, diffusion current under forward bias and reverse bias, applications of diffusion current, conclusion. Let me move to the introduction. In a PN junction, diffusion current arises from the movement of charge carriers, both the electrons and holes, from region of higher concentration to the region of lower concentration. This diffusion current flows due to the concentration gradient across the junction. Specifically, electron diffuses from one side to the another side. It may be a N side to the P side, and holes diffuse from P side to the N side. So this will occur without the influence of external electric field, or it may be a external supply. So this is clearly indicated in the fundamentals in semiconductor physics and the device operations. Diffusion in PN junctions. So we are well known about this. Electrons diffuse from N region to P region, and holes diffuse from P region to N region. This diffusion leads to formation of the depletion region. If you are connecting P-type and M-type substrate, it forms a depletion region by recombination of electrons and holes near the junction, and it devoid of free carriers. This region is called a depletion region. The electric field, if you are applying, means it will develop across this junction, opposing further diffusion. This diffusion current will only without applying an electric source. Establishment of equilibrium. In this equilibrium state, so what will be the equilibrium state? If you are having a concentration gradient in a P substrate or N substrate, it tends to move from higher concentration to the lower concentration side, and it will attain or achieve the equilibrium position. So here the equilibrium is mentioned when the diffusion current and the drift current are equal, and it should be an opposite. That is what we call as an equilibrium at this point of level. So drift current is nothing but, if you are applying an electric field, the free electrons are drifted from N side to the P side. So diffusion current is not applying electric field, drift current is with the application of electric field. Diffusion current under forward bias. When forward bias, P side is positive and N side is negative, the diffusion current increases because the applied voltage reduces the potential barrier and allowing more carriers to cross through it. So we are connecting one PN junction diode, and with a resistor. It may be a current limiting resistor, or it may be considered as a load resistor. Result in this significant increase in diffusion current will takes place. Diffusion current under reverse bias. In reverse bias, we well known P side is negative and N side is a positive. The diffusion current increases in forward, but here diffusion current is reduced as a potential barrier increases, so hindering the movement of majority carriers. Only the small leakage current flows due to the minority carriers. Gently reduces the diffusion current in the reverse bias operation. So this diffusion current is applicable or application in normal PN junction diodes or transistors, and it will also plays a vital role in the operation of photovoltaic cells, it means solar cells. Influence the behavior of semiconductor based sensors also. So all places this diffusion current will be playing a vital role. Yes, diffusion current arises from carrier concentration gradient in the semiconductors P substrate or N substrate, and it will balance with the drift current to establish equilibrium in PN junctions. This understanding diffusion current is crucial for designing and analyzing the semiconductor devices such as diodes, transistors, MOSFETs, field effect transistors, thyristors, all thyristor families, etc. Let's come to the one more thing. There is a relationship between drift current to the diffusion current. The diffusion current is balancing by the drift current due to minority carriers, and it will keeps an equilibrium. The drift current is caused by the electric field in the depletion region. Yes. Thank you.